The velocity of an object is shown in the graph below. Calculate the distance traveled over 5 seconds by finding the area under the curve. So the distance is the integral evaluated from 0 to 5 of this function dx. Now, we haven't been given any means at this point of how to compute an integral. And even if we had, we don't really have a function, we just have a graph. So the best thing that we can do is try and figure out what the area is under this curve using geometry. The way we do that is just split this up into regions that are familiar. So for instance, one way I could do this is I could make this a rectangle that I can easily find the area of that, and then I have a triangle sitting on top of it, and I could use that. Or if I happen to remember the area of a trapezoid, I could use a trapezoid. It's up to you, but personally I will go with rectangles because I know the area of rectangles. Now another thing is, if you'll notice, this is a unit scale, so it's 1 unit this way and 1 unit this way per tick mark. So what that means is area is actually fairly easy to compute there, because the area of this, even though it looks like a rectangle and not a square, is 1, because it's 1 unit in length and 1 unit in height. So if we just count up all the rectangles, that will get us started. So this is 2. This has an area of 3. This has, well, actually, let's just expand that and make it bigger. This right here has an area of 10, because there's 10 squares in it. And this one has an area of 1. So now it's just a matter of how much area is contained in these regions here. So to do that, we can just use the area of a triangle. That's fine. The area of a triangle is a basic formula that you should know. It's 1/2 of base times height. So you could take the base 1, the height 1, and then divide by 2. So the area of this would be 1/2 of a unit. And doing the same logic for this one, the base is 1, the height is 2. So 1 times 2 is 2 divided by 2. That area is 1. And this has a base of 1, a height of 1, 2, 3, 4. So 4 times 1 is 4. 4 divided by 2 is 2. So this has an area of 2. Now we can just add these all together. So 2 and 3 is 5, 6, 16, 18, 19 and a half. So 19.5 would be the distance traveled. And since we're not, well, we are given it, it's in meters per second, so the distance would be meters. And you might be thinking to yourself, like, what kind of an argument is that? But the thing is, we're just connecting the concept of an antiderivative evaluated over an interval is just the area under the curve. All I did there is just compute how much area is underneath that curve. So it's a perfectly valid answer.